Okay, so I'm checking before I continue. I'm checking the folder for last week. So these are the students submitting the work for the tutorial. Okay, the tutorial questions that we have discussed. But I think 3 other students haven't submitted. Okay, so it raised my concern that whether you really understand, you really practice. Okay. So my purpose here is just want you to practice the question, and you know when come to maths, when you practice, you understand. Okay, so for the students not submitting, I'm afraid that I think when come to the class, I will ask them question to ensure that they really understand. Okay, so yeah, okay, let me continue with the questions here. Okay, okay, questions number 9. Okay, last lecture class, we covered the simultaneous equations again for 3 unknowns and using Gaussian elimination method and also the Cramer's rule. Okay, so let's look at the, okay, let's look at the questions 9 and 10 using Gaussian elimination method. Then for other 3 questions is using Cramer's rule. Okay, and as I say, there are many possible ways to solve it with the elementary row operation. You may have a different rows operations, but you can still able to solve the question. Okay, before we start, let's have a recap. Okay, so okay, students say after doing the assignment, I think Gaussian is easier than Cramer's. Okay, so for Gaussian, right? If you understand how to do the elementary row operation, actually is fine. But I just found it when come to the elementary row operation, right? Sometimes people tends to do the wrong calculation. So that's a problem, okay? That's what I think. But once you solve it until you get the upper triangular, so actually it's very easy to solve, okay? Okay. Then for Cramer's, maybe you don't tend to make so much of the careless mistake, okay? So then Gaussian, you need to think on the operation. So some people they think, oh, it's also quite depends on your matrix. So for some of the metrics that you have, using Gaussian maybe is a lot of calculation. So it's actually quite depends on the matrix. So quite depends on the matrix given. Okay. Okay. Now let's have a recap. Some matrix given is easy, so that's why when you do the Gaussian elimination method is easy. Okay. Now, okay, just have a quick recap on the Gaussian elimination method. Okay. So for Gaussian elimination method, okay, we will write the equations in the augmented matrix first. Okay, we'll write the matrix in the augmented matrix, the equations in the augmented matrix. Okay, so and splitting the values at the left and right by a straight line. Okay, then we will conduct the elementary row operation. So we will start with the first column by changing these two second and third elements become 0. Then we will, of course, start from the second followed by the third value. Then after that, we proceed to the second column to using the elementary row operations to get 0 for the last value. Okay, then once we get to these steps, right, then we can solve it. We can solve the equation, okay, by starting from the third row. Solving from the third row followed by the second row and followed by the first row. So this is a Gaussian elimination method. Okay, so now let's look at the questions that we have here. Okay, for this question. So for these questions, right, okay, we have x, y, z equals to 4, 2x minus 3y plus 4z equals to 33, 3x minus 2y minus 2z equals to 2. So the first step we are going to, as I mentioned just now, we are going to present the, okay, we are going to present the equations into the augmented matrix. Okay, so this is an augmented matrix, right? Okay, this part. So this one, we find the augmented matrix. Okay, so by taking the coefficient, for the x, we have 1, 2, 3. For the y, we have 1, negative 3, and negative 2. For the z, we have 1, 4, and negative 2. Okay, then we put the straight line for us to write the values at the right-hand side of the equations, which is 4, 33, and 2. Okay, so we start with this as the first one. Okay, then after that, we will start to conduct the elementary row operation. So as I say, there are many ways to solve it. Okay, so now my target is to change this to a 2. So then I will have the operations on the second row. Okay, so what is my operations here? Okay, so okay, for second row, so I'm taking the first row multiplied by 2 and then okay, then plus negative of the R2. Okay, that means minus R2. Okay, okay, wait. Normally I used to do like this, but it's also correct. Okay, I will put negative 2R1 plus R2. Okay, negative 2R1 then plus R2. Okay, so if I put as this operation, okay, so can you see the changes is only made on the second row? So for the first row still remain, and for the last row also remain. So the changes is only on the second row. Okay, so now taking the first row multiplied by negative 2, then plus the values of the second row. Okay, so start from first column, 1 times negative 2 is negative 2. Okay, then when you multiply, then add with 2, so you get a 0. Okay, then for the first row, you multiply by negative 2 plus negative 3 in the second row, so you get a negative 5. Okay, so next column, third column, okay, then multiply by negative 2 plus 4, so you get a 2. Okay, then for the 4, number 4, right, number 4 times negative 2 is negative 8, so negative 8 plus 33. Okay, so you get 25. Okay, so that's how I write my answers for the second row. Okay, if you're using the different operation, then your answer for the second row will be different with my answer. Okay, so as I say, they have a multiple way to do it. Okay, let me continue. Okay, so next one. Okay, then I proceed to the next step. Okay, for the next, I would like to target these. Okay, these three, I would like to make it as a 0. Okay, then what is my next elementary row operation? So since the first row, they given you a very easy numbers to solve. They give you 1. So for the next one, I can, for the third row, right? Okay, I would like to have a negative 3 multiplied with first row, then plus third row. Okay, taking the first row times negative 3, then plus third row. Okay, so that means right now, since the changes, the operation is on third row, so first 2 rows, the values are all remain. Okay, so this one remain. So our changes is on the third row. Okay, so the first row multiplied by negative 3 plus 3, you get a 0. Then second column multiplied by negative 3 plus negative 2, so negative 5. So third column, 1 times negative 3 plus negative 2, also negative 5. Then for 4 times negative 3, which is negative 12. So negative 12 plus 2, you get a negative 10. Okay, so this is the answer for the third row. Okay. Okay, so now we settle the first column. Okay, first column settle because you already got 2 zeros. Then the next is come to the third column. We want to make this to become a 0. Okay, we want to make this to become a 0. Okay, guys, I know why you say this is easy. To be frank, this question, right, because they give you the easy figures to work on it. The first row, they are all with the values of 1, so it's easy, right? Okay, so now come to the third row again. Okay, second column. So we work on the third row again. So that means the first 2 rows should be remain. Okay, now these times, right? Okay, say okay, I just want to change the second column third value to be a 0. So I cannot apply first row because if I apply first row on the third row, right, this one can't remain as a 0. So remember this one we want to remain as a 0. Okay. So this one we want to remain as a 0. So we don't want to change this, right? Okay. So what we can do is we have to apply what we have in the second row. Okay. So we need to apply second row, okay, to get the 0 for the third row. Okay, so still R3. Okay, what I want to do right here is, let's say for the, okay, so for the second row, I have negative 5, right? Okay, then let's say I take negative multiply with the second row, then plus the third row. Okay, so that means if I take negative 5 times negative again, I get positive. Then positive 5 plus negative 5, I get a 0. Okay, so now, okay, I get a 0 here. Then continue with the second column. 2 times negative is a negative 2 plus negative 5, so is negative 7. Okay, negative 7. Then for 25, right, you multiply by negative. Then plus negative 10, so you get negative 35. Okay, so this is my answer. Okay, okay, now I already have all the 3 values are 0 here. Okay, so that means I achieved the upper triangular. Okay, that means I can stop here already. Okay, so what I need to do for the next, I need to solve the equation. So when I solve the equations, I start to solve it from the third row. Okay, remember we solve it from the third row. So remember these 3 rows is representing, first column representing X, Y, and the third is a Z. Okay, so when we start from the third row, that means negative 7X equals to negative 35. So I managed to solve the X as a 5. Okay, I get X as a 5. Okay, then next, I will come to the second row. Okay, second row is actually negative 5, which is for negative 5y. Then plus 2x equals to the values at the right hand side is 25, right? Okay, so let's substitute x as a 5. Okay, then you will get negative 5y plus 2 times 5 equals to 25. Okay, so you try to solve this one. Negative 5y plus 10 equals to 25. That means negative 5y equals to 25 minus 10, which is 15. So y equals to negative 3. Okay, then next come to the first row. So first row, you have the values of 1, 1, 1 equals to 4. So that means which is x plus y plus z equals to 4. So let's substitute x equals to 5 and y equals to negative 3 that you obtained earlier. Okay, then your x, y, z will become 5 plus negative 3 plus z equals to 4. 5 minus 3 is a 2. So z equals to 4 minus 2. So you get a 2. Okay? Hey, sorry.
Excuse me, Miss. I think your z and x is opposite.
Yeah. I realized already. Sorry, this one should be z. Okay, z. My mistake. So this one is a z. Okay, negative 5y plus. Okay. I mistaken my z. Sorry. Okay, I realized already. Then this one is a z equals to 5. Okay, then correct. Okay, then y equals to negative 3. Then x, y, z equals to 4. When x equals to 5, y equals to negative 3. So x plus y plus z, z is 5. Okay, 5 minus 3, so your x is equals to 2. Okay, x equals to 2, y equals to negative 3, z equals to 5. Okay, so this is our answer. Okay, right? Okay, so I have to say that these questions seem to be easier because of the values given, the coefficients given is easier to solve. Okay, so is that okay? So far?
Yes, Miss. Okay.
Yeah. Okay, so I think you should able to check your answers, okay, for this type of the question. Then I would like to proceed to question 10. Okay, let's practice questions 10 now. Okay, let's do the questions 10 now. Okay, so start with the augmented matrix. Okay, start to write the augmented matrix. Then start with your elementary row operation. Okay, let's try this out. Okay. I think after you go through the Gaussian elimination method and also the Cramer's rule, right, you may have a feeling that you don't want to use the inverse method already. So I guess because inverse method seems to be the one that need the most calculation. Okay, so I think your elementary rows operation may not be same with mine, right? Like the previous questions 9, do you all using the same elementary row operation as I showed just now? You also get the difference, right? To me, I'm more used to that way.
Yes, Miss. I use slightly different.
Slightly different, okay? Maybe the sign is different.
Miss, for question 10, I realized that You don't need always get a triangle 0 to find the answer. As long as you got 3 0, 2 in the same row and 1 in the other row, then you can find the answer.
Okay, your 0 must be will let you find will help you to solve the equation. I think these questions you get a 0 in second equation. I think so. So that's why you can still I can't remember. I think you will get a 0 before you reach the last step.
Yes,
right?
that's
3 zeros, right?
Yeah.
So actually it's true, okay, when you, for these questions, actually sometimes it's quite depends lah, okay? So for these questions, yes, before come to the last step, before you achieve the third 0 in the second column, so you get the 0 for another equation, then you can also solve it. It's correct, okay? But we still always put that as our guidelines, okay? So just in case some people they're not sure, maybe certain sometimes when they get 3 zeros, they may not able to solve. Okay, and this time it so happened that the zeros that you get right, you can able to solve. Okay, so that's why I say it's quite depends on the values of the matrix that you get. So if let's say you get the 0, that can help, that means you'll make your equation become one unknown only, then you can solve. Then I think you may not necessarily to reach up to the upper rectangular. Okay, but as I say, it depends. Okay, so to me, I will still show up to the step. Okay, for this case, of course, later I will show you. Okay, when come to second step, maybe we can solve already. Okay, but I think I will still show up to the third step. Okay. So because some people may not know when they get 3 zeros, they can actually not need to proceed. So just don't want to make them confused, but I understand what you're trying to tell. Okay. Okay, so now can I have Saad? Okay, so Saad, what is the matrix on the augmented matrix? What is the values on the first row? What should I write? Saad, are you here? Saad, what is the values on the first row? Okay, I'm not sure whether, okay. Cryptocon?
Yes, miss.
Okay, what is the matrix, augmented matrix? Can you give me the value on the first row?
1, 2, 1, 4.
Okay, then second row?
3, -4, -2, 2.
Okay, correct. Okay, then?
5, 3, 5, -1.
Okay, thank you. Okay, so okay, now let's proceed. Once we get the augmented matrix, then we will proceed for the rows operation. Okay, so as I say, we'll target on making this to a 0. So we will target on the second row. Okay, so since the first values you have on the top is 1, then will be easier for you to solve. So let's say I take the negative multiply with the first row, then I add with second row. Okay, so since the operation is only on the second row, so the first row and third row value is remain. Okay, so now 1 times negative, sorry, I forget about 3. Okay, negative 3, huh? Okay. Negative 3R1. Okay, negative 3R1 plus R2. Okay, so negative 3 plus 3 is a 0. Okay, then negative 3 times 2, negative 6 plus negative 4, negative 10. Okay, negative 6 plus negative 10. Okay, then for number 1, third column, negative times negative 3, negative 3 plus negative 2, negative 5. Then next for number 4, right? 4 times negative 3 is negative 12. Okay, negative 12 plus 2, negative 10. Okay, so we get the value for the second row.
Excuse me, miss.
Yes?
Miss, for the formula right in the middle, it can be also 3 times R1 minus R2, right?
Yes. Okay. So that means other way, you can also put as 3 times R1 minus R2 is also getting the same answer. Okay. You will also make it as a 0. Okay. Now, okay, next. Okay, next we would like to target this to make it as a 0. Okay, so we can apply what we have from the first row. Okay, now we can also have it as a third row, right? So I'm taking negative 5 times R1 plus R3. Okay, negative 5 times R1 plus R3. Okay. So we remain the answers for the first two row. Then get the answer for the third row, okay? Okay, now, negative 5 times R1 for the first column, so plus 5 is a 0. Then second column, negative 5 times 2 is a negative 10. Negative 10 plus 3, so which is negative 7. Then third column, negative 5 times 1, negative 5. Negative 5 plus 5, which is a 0. Okay, then for 4, right? 4 times negative 5, negative 20. So negative 20 plus negative 1, which is negative 21. Okay, so I think this is what you mentioned just now, okay, from Samuel. Okay, so we are supposed, no, our normal step, we will proceed until this one become a 0. Okay, but what happened for this equation is so happen that we have a zeros here. Okay, we have a zeros for the third row. Okay, so the third row we have 2 zeros. When the third row have 2 zeros and the 2 0 is happen at the left, not happen at the right. Okay, happen at the left. Okay, then that means if I referring to the last row, it will give me the equation with one unknown. Okay, that means I can solve the values for the y. Okay, I can solve the values for the y. Okay, but this one let me show you separately later. Okay, so let's say I just proceed as a normal steps that I have. Okay, so as a normal steps that I have, then I should proceed. Okay, I will proceed until I get the second column, the third value become a 0. Okay, if I continue, then what should I do here? Okay, what should I do here? Okay. Okay, so I'm going to apply what I have on the second row, okay, instead of the first row. So that means for the next step, my operation still on the third row. Okay, then I remain the first 2 rows. Okay, so since I need to do it on the using the second row, right? Okay, so maybe what I can do is for the negative 10, okay, how I make it as a positive 7 so that when I add with negative 7, I get a 0. Okay, so that means I will divide it by okay, I will multiply by a negative over 10. Then multiply by 7, R2 plus R3. Okay, so I divide by 10 so that the 10 become 1. Okay, then I multiply by negative 7. Okay, so I get a positive 7. Okay, so can you see negative 7 over 10 when I multiply by negative 10? So I get a positive 7. So when I get the positive 7, then I add with the third row, so I get a 0. Okay, I get a 0. So that's what I plan to do. Okay, on since the second for the second row, the first value is 0, right? So when you multiply a negative 7 over 10 plus R3, you will still get the same answer. Okay, so as I say just now, this one should be a 0. Okay, then come to the next one. Negative 7 over 10 times negative 5. Okay, so you get 7 over 2. Okay, 7 over 2. Yeah, okay. Then next one will be negative 10, negative 7 over 10 times negative 10. So you get a 7. 7 plus negative 21. You get negative 14 here. Okay. Then next you solve it. Okay. So if you start from this equation, 7 over 2z equals to negative 14. So negative 14 divided by 7 over 2. So you get negative 4. Okay, so this is not a z, sorry. This one is R1, R2, R3. Okay, so that means your values, this is R1, this column, R2, then R3. Okay, so that means this one's supposed to be I3. Okay, I3. Okay, so then I will get I3 as a negative 4. Okay, then I proceed to second row. Okay, so which is a negative 10 I2 minus 5 I3. Okay, negative 10 I2 minus 5 I3 equals to negative 10. So when I3 equals to negative 4, then you will get negative 10 I2 minus 5 times negative 4, then equals to negative 10. Okay, so you will solve it to get I2. Okay, so this one plus 20. Okay, so you have negative 30 divided by negative 10, so you have a positive 3. Okay, this one you get a positive 3. Then we proceed to the first row. Okay, then it will be I1 plus 2 I2 plus 3 plus I3 equals to 4. So when I3 is negative 4 and I2 is 3, then what is the I1? So I1 plus 2 times negative 4 plus 3 equals to 4. So you solve it for I1. Okay, so 3 minus 8. Okay, then 4 plus 5. Wait, negative 8. So 5 here. Okay, negative 5. Plus 5. Okay, wait, do I do it wrong? I1 plus 2I2 plus R3 equals to 4. I3 equals to negative 4. Oh, sorry. Substitute it wrong. Okay, that is negative 3. Okay, I2 is 3, sorry. Okay. Hi. Okay. So you get a 2. Okay. Then this is your answer. Okay. So this is if you are doing it until 3 zeros here. Okay. But as I say just now, okay, for this case, right, you can also stop it here and get the answer. Okay, you can also stop it here and get the answer. If you stop it here and get the answer, I think it seems to be easier. Okay, so if you stop here to get the answer, why? Because at the third row, you have 2 zeros here. That means your third row, you have the equations of, this is I1, I2, and I3. Yeah? Okay, so for the third row, you have negative 7I2 equals to negative 21. So from here, you can solve I2 as a positive 3. Okay, then followed by second equation. Okay, so as long as you have only one unknown, then you can solve it. Okay, then second row, because you have 1, 0, you have 2 unknowns. Okay, with the I2, you substitute and you can solve it. Okay, so if I continue, so I have negative 10 I2 minus 5 I3 equals to negative 10. So substitute I2 that we have, negative 10 times 3 minus 5I3 equals to negative 10. So you can solve for I3. Okay, so negative 10 plus 30. Okay, 20 divided by negative 5. So you get a negative 4 as well. Okay, then come to the first row. Okay, first row you have I1 plus 2I2 plus I3 equals to 4, right? Okay, substitute, you need to solve I1, substitute I2 as a 3, then I3 as negative 4 equals to 4, okay? So you get I1 equals to 2, okay? So which is a 2, 3, negative 4, okay? Okay, so understand? Okay, let me see what is posted in the chat box. Okay, Wei Huan, okay, can I solve R3 without following the order? I don't understand. It seems to be everything is correct here. Wei Huan, what do you mean by solving it without the order? I can see, yeah, based on your equation, definitely you have to solve for I3. Then once you get the I3, then you need to use a second equation to solve for I2. Then come to first equation. To me, everything looks fine.
Miss, I think he meant in terms of changing into 0 the order. That's what I think lah.
Okay, so he changed from first column. Okay, then after that, oh, he's not changing. Okay, he's changing this. Okay. Okay, can you see, okay, let me comment on this, okay? So actually, this is a good question. Okay, so if we refer to the workings from Wei Huan, right? So he changed this to 0. Normally, we will change the 0 on the first column, the third value. We will proceed to change this as a 0, but he didn't change this to 0, but he changed this to 0. Okay, so when we do that, right, if we don't follow the sequence, okay, so when we go to the next step, okay, when we go to the next step, when we want to change this to 0, right, there is a chance that the 0 you obtained just now may be affected. Okay, the 0 you want to, that you already obtained earlier, may be affected. You get what I'm trying to tell you? So that's why there is a reason why we follow the sequence. Follow the sequence will make it easier to do it. Okay, will make it easier to do it. So because, okay, when you change this to 0, then followed by this, right? Okay, then when come to this one, you want to change this to 0, you can using the second row. Okay, you can using the second row without affecting this one, which is already in the 0. Okay, that's what I'm trying to say. Okay, but if let's say you do you don't follow the sequence, this one get a 0, then you come to here get a 0, but later when you want to get this as a 0, most probably you have to use maybe second row or even first row, then there's a chance that the 0 that you obtained earlier will become non-zero again. So Wei Huan, you get what I'm trying to tell you? Yes, huh? Okay. So that's the reason why we follow. Okay. Okay, and I think here, when you do it, okay, this one no issue. Then 3R1, then you do 3R1 minus 2R3. So okay, this one you get a 0. Right? Okay. It's quite depends on your luck. So sometimes maybe you have some things that is easy, you can solve it without having this problem. Okay, so you may not be having such an easy way of doing it come to other metrics. Then when come to the next one, R2 times R3. R2 times R3. Okay, wait. So I saw this part. Actually, so far, I never try for elementary rows operation, right? This is not something common. Taking another row times another row, okay? This is not some things that I commonly see, okay? We may have some things like that. We may have a scalar multiplication. For example, let's say R3, we have half times R3. Okay, this is possible. Okay, this is possible. Okay, the row operations such as R1 minus R3, this is fine. Okay, or some things like negative 3R1 plus R3, this is okay. But I hardly see some things like taking one row and multiply by another row. But I can see right here you get it right. Okay, the answer is still correct. Okay. So this one, I think I have a doubt, okay? Because normally I don't see the elementary row operation is conducted by this way, okay? It's not common, okay? Okay, but I would like to, this one I will look into it again, okay? But as I say, that is not common, okay? Okay, let me see another, okay, so, okay, this one is working. Okay, yeah. So from Samuel, he's actually stopped at the second step when he get 2 zeros at the last row. Okay, for this case, yes, you can still solve it, not an issue. Okay. Okay. Is there any other question? Is there any other question? Okay, in the future, when come to the revision for second test, then I think I will give you more questions to practice. Okay, then you know some of metrics may not be that easy to solve. Okay, so if you found it easy to solve, it's because of we are giving you an easy matrix to solve. Okay, then let me proceed. Okay, if you have no other question. So questions 9 and 10 already settled. Then come to questions 11, which is a Cramer's rule. Okay, so when come to Cramer's rule, okay, let's have a quick recap. Okay, so for Cramer's rule, we will find the determinant of the matrix first. Okay, determinant of the matrix first. And if I refer to the equations here, okay. So we are taking the values from the x, y, z, the coefficient from the x, y, z, okay, for the matrix, okay. The first determinant we want to find, okay. We just get the coefficient from here first, okay. Then get the determinant, okay. Then when come to other determinant, okay, then for example, determinant for the x, okay, so this is the x, y, z. Then for the column of the x, we will substitute with the values here, okay, 533. Then we find the determinant, and after we find the determinant, we will using the determinant x divided by the determinant and get the answer, okay. So we are doing the same things for others unknowns, which is y and z. Okay, so that's the way, okay. So now for this question, okay, first we find the determinant. Okay, or you just write a delta. Okay, so you need to find the determinant for 1, 2, 3, 1, -3, and -2. Then 1, 4, -2. Okay, find the determinant. Okay. Before you proceed to others. Okay, so this one also try to make it easy for you, because if you're using the first row, all the values are 1, right? Okay, so I just proceed to find the determinant by blocking the first row, first column. So I have a -3, -2, 4, and -2. Then the second one supposed to be a minus sign, okay, and the value is 1, okay. Then blocking first row, second column, I have 2, 3, 4, -2. And third one is a plus. Okay, so blocking first row, third column, I have 2, 3, -3, and -2. Okay, then I proceed to get the determinant. Okay, so this is 6 plus 8. Okay, minus -4 minus 12, then plus -4 plus 9. Okay, then you get the answer. Okay, so your determinant, you get 35. Okay, then next, okay, so since this is x, y, z, right? Okay, so this is the x, y, z. Okay, so for the next determinant of the x, okay, I will replace the first column as values at the right hand side here. Okay, 4, 33, and 2. Okay, for the column x, okay, you substitute as 4, 33, and 2. So the rest remain. then you just find the determinant as usual. So this one is a 4. Then second one will be a minus. Then third will be a plus. Okay, so blocking first row and first column, you have -3, -2, 4, and -2. Then for the second one, blocking first row, second column, 33, 2, 4, and 2. Okay, third one, okay, blocking first row, third column, 33, 2, -3, and -2. Okay, then calculate for the value.
Hi, Miss.
Yes?
The second one, right? 33, 2, 4, and -2. You forget to put a negative.
Oh, okay, thank you. Okay, thanks. Okay, let's proceed. Okay, then for the 4 multiplied by 6 plus 8, okay, then this one minus, you have 33 times -2, -66 minus 8, then plus -66 plus 6, okay, then get the determinant. Okay, so what is the determinant you get for the delta for x, students?
70.
70, yeah?
70.
Okay, thank you, 70, yeah? Okay, let's proceed for the determinant for y. And this time we are substitute the second column. Okay, second column for the values of 4, 33, and 2. Okay, 4, 33, and 2. So first and third column will be remain. So your first column, which is 1, 2, 3, yeah? Okay, then let's proceed as usual. Okay, so you have a 1. Okay, then the determinant will be 33, 2, 4, and -2. Then second one is minus sign. So you have a values of 4. Then the determinant will be 2, 3, 4, -2. Okay, then the last one is a 1, positive sign. Then blocking first row, third column, 2, 3, 33, 2. Okay, then let's calculate the value. -66 minus 8 minus 4 times -4 minus 12 plus, okay, 4 minus 99. Okay, so what is the determinant for y, students?
-105.
Okay, -105. Thank you. Okay, then proceed to the determinant for z. Okay, so this time we replace the third column, okay, as 4, 33, and 2. Okay, first two column remain. So first column is 1, 2, 3. Second column is a 1, -3, and -2. Okay, so values of 1, determinant blocking first column, first row, -3, -2, 33, and 2. Then this one is minus. Okay, then the determinant blocking first row, second column, 2, 3, 33, and 2. Okay, then the last one, which is a 4. Okay, then 2, 3, -3, and -2. Okay, then find the answers. Okay, so -6 plus 66 minus 4 minus 99 plus 4 times -4 plus 9. Okay, so what is the last one? What is the determinant for z?
175.
Okay, 175. Thank you. Okay, now these are how you find the determinant. So of course, this one involves some calculations here. Okay, so after you get all the determinants, then you can find the values of the x. So the values of the x is actually a determinant of the x divided by the determinant. Okay, So determinant of the x, we get 70 divided by determinants, okay, which is this value, 35. So divided by 35, you get the values of 2, okay. Then how about y? So y equals to determinant y divided by determinant. So determinant y is a negative 105 and the determinant is 35. So you get values of negative 3. Okay. Then next one for the z. So z is determinant z divided by the determinant, right? So the z is 175 divided by 35. So you get a positive 5. Okay. So that's how we get the answer. Okay. So basically this, okay, so when I say Cramer's rules is easy means it's already a fixed method to do it. You don't need to think, okay? But for Gaussian elimination method, then you have to figure out how to do the elementary row operation. That's a different. So that's why it's quite depends. So that's why some may think that the Gaussian is easier, okay? So that's the way we do it. Okay, is that clear? Yes, huh? Okay. So, okay, it's 3:30 already. Okay, I give you a 10 minutes break. Okay, we still have 2 more questions to go. Okay, 12 and 13. So later, this 12 and 13, I need the students to do it, and I want to see your solution. So I think maybe 12 will be a bit difficult to calculate because it involve 1.4, 2.8, and so on. Okay, so that will be the next question. Okay, so let us have a short break. Okay, then maybe I just remain this page, okay, for you to refer. Then later we'll continue 12 and 13. So if 12 and 13 we can finish before 4:30, then I may start the new topic, okay? Okay, so 10 minutes break. Okay, see you after 10 minutes. Okay, students, let's continue. Let me take the attendance first. Okay, so T4. Okay, take your attendance. Okay, so all present, right? Okay, let's proceed. Okay, so as I mentioned just now, we will continue the next question. Okay, question 12. Okay, I see the message from Ziyi. Okay, so for this method, we need to find 4 determinants, and others also answering yes. Okay, correct. So that means for questions for Cramer's rules, you need to solve by finding 4 determinants. Then after that, you can get the unknowns. Okay, the formula is simple, just a lot of calculation. Okay, now. Before that, okay, so as what I mentioned just now, we need to start with the first matrix, right? Okay, so basically so you need to know how to find a matrix. So basically your matrix can split into this part and also this part. Okay, for these values, okay, then you have to put it in the matrix to get answers. Okay, can I have Kai-Feng? Kai-Feng, can you tell me what is the values I should put in the determinant? Kai-Feng, what should I put for the first one? What should I calculate? Tang Kai-Feng? Kai-Feng, are you here? Okay, it's okay. You haven't done until 12, it's okay. You just tell me now, okay? What should I put in the first determinant? What should I put for the first determinant? Okay, so first row will be 1.4. Then first row, what is the first row? Okay, 2.8. I think you can type in one message, else you are going to type 9 times. Okay, 2.8. Second row, 4.2, negative 1.4, and 5.6. Okay. Then for the third row, 4.2, 2.8, negative 1.4. Yeah. Okay, so correct. Okay, then you will proceed to find the determinant. Okay, so for this one, the calculation more complicated already. Okay, if you're using the first row, then will be, we have positive minus positive, right? So then the first one will be 1.4. Then the second one will be negative 2.8. Then the next one is a 2.8. Okay, okay. Then what should I put for the first determinants here? Okay. Can I have Saad? So Saad, is it okay? Just how you say you have a problems with team, but you still can answer my question in the chat box. So you can answer my question in the chat box if you can't talk. Okay, so what should I put for the first determinant here? Blocking first row and first column. So because I need to ensure that students know how to do this, okay? Okay, negative 1.4, then 2.8, 5.6, then negative 1.4. Okay, correct. So for the second matrix, blocking first row, second column. Okay, 4.2, 4.2, yes. Then 5.6, negative 1.4. Okay. Then how about the third one? Okay, third one, we blocking first row, last column. So 4.2, 4.2. Then negative 1.4, 2.8. Okay. Then you proceed for the calculation, right? Okay. So guys, what is the answer for this question? Can you give me the answer in the chat box? Anyone got the answer for this one? So this one need a lot of calculation.
112.
Okay, 112.504.
504.
504, correct. Okay, thank you. 112.504. Okay, next one is the determinant for the x. Okay, so first column is a column for the x. Okay, this time I would like to have Ziyi. Okay, Ziyi, what should I put for the first column?
First column 5.6, 35, and then 5.6.
Negative 5.6. Okay, first one 5.6, 35, then negative 5.6. How about the second column?
2.8, negative 1.4, and then 2.8.
Okay, third column?
2.8, 5.6, negative 1.4.
Okay, correct. Okay, thank you. Okay, then we proceed for the calculation using the values of the first row, 5.6, then blocking first column, first row, so we have negative 1.4, 2.8, 5.6, negative 1.4. Okay, second one is negative 2.8, then blocking first row, second column, 35, negative 5.6, then 5.6, negative 1.4. Okay, then the third one is a positive 2.8. Okay, blocking first row, third column, so 35, negative 5.6, negative 1.4, 2.8. Okay, so calculate the values. Okay, next, what is the answers here? Anyone have the answer?
225.008.
Okay, 225.008. Yes, correct. Thank you. Okay, so this is a determinant for the x. Then let's proceed for determinant of the y. Okay, so determinant of the y means we need to substitute the second column as a 5.6, 35, and negative 5.6. Okay, so as I mentioned here, okay, this one. Okay, then the first and the third column are remain. So this is the third. Okay, then the first column, which is this one, 1.4, 4.2. 4.2. Okay? Okay. Then proceed for the calculation, 1.4. Then 35, negative 5.6, 5.6, negative 1.4. Then for second one, you put minus 5.6. Okay, so blocking first row, second column, 4.2, 4.2, 5.6, negative 1.4. Then third one, so it's a 2.8, right? Okay, then 4.2, 4.2, 35, and negative 5.6. Okay, so anyone get the answer for determinant for y?
Negative 337.512.
Okay, yes, correct. Thank you. Okay, then next we will proceed to delta z. Okay, the determinant for the z. Then we should substitute the third column as the values of 5.6, 35, and negative 5.6. Then the first column remain as 1.4, 4.2, 4.2. Second column is 2.8, negative 1.4, and 2.8. Okay, so then calculate again. Okay, so 1.4, okay, negative 1.4, 2.8, then 35, negative 5.6. Okay, then minus 2.8. Okay, minus 2.8, then 4.2, 4.2, 35, and negative 5.6. Okay, then last one plus 5.6. Okay, then 4.2, 4.2, negative 1.4, 2.8. Okay, so what is the last answer for determinant of z?
450.016.
450.016. 450.016, correct. Okay, then we proceed to find the values, right, for the unknowns. Oh, sorry, here is F1, F2, F3. So I should put it as determinant for F1, F2, then for F3. Okay, so next I will continue to find. Okay, so this one we need to find F1. So which is equals to determinant for F1 divided by determinant. Okay, so just now we have 225.008, then divided by the determinant here, 112.504. Okay, so what do you get for F1? Exactly 2. Okay, so next one, F2. Okay, so for F2, which is determinant for F2 divided by determinant. Okay, so determinant for F2, which is negative 337.512 divided by determinant 112.504. Okay, so second one, you get negative 3. Okay, and the third one, okay, F3. So F3 equals to determinant F3 divided by determinant. So 450.016 divided by 112.504. So your answer is last one, positive 4. Okay, so that's the way on doing it. Okay, so is that okay?
Yes, miss.
Yes, okay, so we have one last question. So yeah, can I have any students who already complete these questions to share their solution? Any volunteer? For questions 13. Who got the answer? So actually questions 13 is the same as earlier one. So the answer is the same, but just the method is different, the working is different. So we already know the answers for this one, right? It should be I1 equals to 2, I2 equals to 3, and I3 is equals to -4. So we already know this is the answer because it's the same as questions 10, okay? So we just need the methods. Any of you already done? Okay, can I have a look here? Who is the students? Okay. Can I have Manheng? Have you done the question? 13? Manheng, have you done 13? Haven't. Okay, so then you have to do it now. Okay. How about the... Okay, do it now, huh? Okay, then I have another students. Okay, how about Harold Lim, Jing Yan? Have you done the question? Yes, huh? Okay, please share your solution. So for the rest haven't done, please make sure you do it now. Okay, so just wait for Jing Yan to share his solution. So after the last question 13, then we can proceed to new topics. Okay, so I can see the working share by Jing Yan. Okay. Oh, okay. So no wonder there's another page, because I wonder, how come only one answer? Okay. Okay, so now let's look at the solutions from Jing Yan. Okay, so find the first matrix. Okay, so 1, 2, 1, 3, -4, -2, 5, 3, 5. Okay, so will it be too small? So let me drag it larger. Okay, drag it to the max. Okay, so I think now see it clearly. Okay, so taking from the original equation, so 3 minus 4 minus 2, second row, third row will be 5, 3, 5. Okay, correct. Then you just find the determinant. Okay, this one correct. Then -2, then 3, 5, -2, 5, correct. Then 1, then 3, -4, 5, and 3. Okay, so correct. Okay. Then, so the determinant is -35. So the rest of the students already done. Do you get -35 as well? Is that correct?
Yes, miss. Correct.
Yes, huh? Okay, thank you. Okay, so next one is a determinant for I1. Okay, so this one is determinant for I1. Huh? So determinant for I1 means you have to substitute the first column, okay, as the values here. Okay, 4, 2, negative 1. Okay, correct. So the rest is remain. 2, negative 4, 3, 1, negative 2, 5. Okay, so correct. Okay, then find the determinant. 4, then negative 4, 3, negative 2, 5, correct. Negative 2, then 2, negative 1, negative 2, and 5. Then this is plus 1, which is 2, negative 4, negative 1, and 3, correct. Okay, so determinant for I1 is negative 70. Okay, is that same answer as yours?
Yes, miss. Same.
Okay, same, thank you. Then we can find the R1 by taking determinant for I1 divided by the determinant of negative 35. So negative 70 divided by negative 35, which is 2. Okay, so correct. So the I1 should be 2. Okay, then we proceed. Okay, determinant for I2. This one is I2. So I2 means the second column. We replace it as 4, 2, and negative 1. So the first column 1, 3, 5 remain. Third column 1, negative 2, 5 is remain. Okay, correct. So then the workings 2, negative 2, negative 1, and 5, correct. Second column negative 4, correct. So 3, 5, negative 2, 5, correct. So plus 1, then 3, 2, 5, negative 1, correct. Okay, then the answer is negative 105. Is that correct?
Yes, miss. Correct.
Okay, thank you. Then divided by negative 35, so we get positive 3. Yep. Okay. Then next one is a determinant for I3. That means the third column for I3, you are replacing with 4, 2, negative 1. Then the first two columns still remain. So first column is a 1, 3, 5. Second column is 2, negative 3, negative 4, and 3, correct. Okay, then we proceed to find the determinant. So negative 4, 3, 2, minus 1. Negative 2, 3, 5, 2, negative 1, correct. Positive 4, 3, 5, negative 4, 3, correct also. So 140, is that correct?
Yes, miss. Correct.
Okay, so divided by negative 35 for the answer just now, then we get negative 4. Okay, yeah. So that's how we solve it. Okay, so this is the workings from Jing Yan is correct. Okay. Okay, so we have done this tutorial. So is there any question? Because I would like to start a new topic. Is that clear so far?
Yeah, clear, miss.
Everything
Okay.
clear so far.
Okay, thank you. Thanks for the feedback. Okay, then let's proceed to our third topic. Okay, so what is our third topic here? So the third topic is about complex number. Okay, so I think this topic should be new to you. I think you never learned about this. Okay, for the maths that you learned in your high school. Okay, so this is something new to you. Okay, so now you may wondering what is the meaning of complex numbers. Okay, before we start, let's look at the topics and structure of the lesson. So we are going to go through on the basic operations of the complex numbers. Then how the complex numbers also can present as in the Argand diagram. Then when it comes to complex numbers, there's a different form of the complex numbers. So we will go through other form of the complex numbers, which is polar form, exponential form, and then conversion from one form to another. Okay, so to be frank, these topics we will go through a lot of the calculation. Okay, the tutorial also there's a lot to go through. Okay, then power of the complex numbers, which we can solve by using the De Moivre's theorem. There's a theorem we can apply. Okay, So this is a learning outcome to solve can apply the knowledge here to solve the engineering problems. Okay, now let's look at complex numbers. What is means by the complex numbers? Okay, so before I continue, okay, so complex numbers is in this form. Okay, it's very common that we may using a Z to represent a complex numbers. If I can, for example, if I write 2 plus 3 square root of -1. Okay, this one is a complex numbers. Okay, so a complex numbers which consists of the real part, this one we call it as a real part, and the one with the square root of -1, we call it as an imaginary part. So this one is a real part, and this part is the imaginary part. Okay, so I think this is something new to you, square root of -1. Because of the square root of -1, so this one we call it as a complex numbers, okay? And we normally have a symbol to represent the square root of -1, okay? So the square root of -1, for general, okay, in the normal maths that you see, we always using I as a notation. Small letters of I as a notation for square root of -1. Okay, but when come to this slide, okay, you can see we always using J to represent a square root of -1. Okay, so when come to the assessment question, sometimes you can see I, sometimes you can see J, then you have to understand that both I and J are referring to square root of -1. Okay, in engineering, we are more using J to represent square root of -1. Okay, why? Okay, because when come to engineering, it's very common that we're using I to represent current. Okay, I is actually the notation for current. So in order not to get confused with the notation of the current, then we're using J to represent square root of -1. Okay, square root of -1. So that means for these figures, I can write as 2 plus 3i, or I can write as 2 plus 3j, okay, which the I or j is represent square root of -1. But as I say, normally when you look at those which is not regarding engineering, okay, not regarding engineering, it's common that we put I. But for engineering, then we may using j, okay. As I say just now, to avoid the confusion with the notation with the current, which is I. Okay, so now, okay, so since I already tell you, okay, this is complex numbers, okay. So for example, complex numbers consists of a real part and the imaginary part. And the imaginary part is actually with the square root of -1. So now your question is, then how come we have this kind of the numbers? Where is the next square root of -1 come from? Okay, so now we look at the quadratic equations we have here. Okay, can you see this is a quadratic equation? And how we solve for the values of the x? So normally we're using factorization, but if we can't able to factorize, then we are going to use the quadratic formula. Okay, so still remember when we have an equation in ax squared plus bx plus c equals to 0. Okay, when we want to solve, okay, the quadratic equation without using factorization, then our formula will be x equals to negative b plus minus of square root of b squared minus 4ac divided by 2a. Okay, so minus b plus minus square root of b squared minus 4ac over 2a. Okay, so I believe you have learned this in the EMTS and of course in the high school. Okay, so this is a formula. Okay, now when we look at the questions that we have here, x squared plus 2x plus 5, right? So that means our a is equals to 1. Then the b is a 2, so b equals to 2. and the C should be 5. So C equals to 5. So now if I substitute A equals to 1, B equals to 2, C equals to 5 into the quadratic equation, so this is what I have, okay? So this is B, so negative 2 plus minus 2 square minus 4AC. So the A is 1, C is 5. Then divided by 2A, so this is 1. Then we try to solve this. Okay, so let's say we try to simplify the one in the square root. Okay, so inside the square root, what I have? So 4 minus 20, so I get a negative 16. So in the square root, we get negative 16. So remember, when we have a negative value in the square root, we can't able to solve this, right? So because this is not a real number, okay? So when you have a complex numbers, means this is not a real number. Remember last time when you learn EMTS, I think it's the first topic, is it? You learn about integer, you learn about real numbers, right? So complex numbers is not a real number. Okay, complex number is not a real number, because last time you learned about real number. You may wondering what it means by the not a real number. Okay, so complex number is not a real number. Okay, now, so let's proceed. Okay, so just now we get square root of negative 16, right? Okay, which I can write it as a negative 1 times 16. Okay, negative 1 times 16. So I can also split into 2 square roots. So I have a square root of 16. Then I have a square root for negative 1. Okay, so we can't able to solve for the square root of negative 1, but square root of 16 I can get as a 4. Okay, so now let's solve this. Okay, so you still have a 2 at the bottom, right? So negative 2 divided by 2, you get negative 1. So 4 divided by 2, you get a 2. Then we have another part that we can't able to do further. We have to remain it as a square root of minus 1. And this square root of minus 1, as I say, we can using J to represent it. Okay, using J to represent it. And then, so when come to engineering maths, right? Okay, instead of writing J at the behind after the 2, we may also write it in front of the 2. Okay, so please take note, this is not wrong. So this is a correct way to do it. Okay, but of course, we can also write the J behind the 2. Okay, so from here, okay, we get negative 1 plus minus J2. So remember when come to plus minus, okay, when come to this plus minus, so for the plus minus, we understand that it's a plus and the other one is a minus. Okay, so for the equation just now, okay, quadratic equation just now, you get 2 complex numbers. One is minus 1 plus J2, the other one is minus 1 minus J2. Okay, and as I say just now, okay, so there's a real part, there's an imaginary part. Okay, so for the complex numbers in general form, we write it as A plus JB. Okay, A plus JB. So which the A is a real part. Okay, the JB is an imaginary part. Okay, and then a complex number of this form, we call it as Cartesian complex numbers. Okay, Cartesian complex numbers. So that means, okay, as a conclusion, okay, so complex numbers, one of the form of the complex numbers, we can write it as A plus JB, A plus JB. So this one as a real part, this one as an imaginary part. So this form of the complex numbers, just how we say, is a Cartesian, is a form of Cartesian complex numbers. There's another name, we call it as a rectangular. Okay, rectangular complex numbers of Cartesian form. Okay, this is the one of the form that we can present our complex numbers. And there's another 2 form, which is a polar form and also the exponential form. That will be the later part. Okay, but let's get familiar with this Cartesian and rectangular form first. Okay, so can you understand? what is the complex numbers now? Okay, guys? So do you
Yes,
get
miss.
Yes, okay. Okay, so now before we proceed to next part, okay, so this is what I want you to do. Okay, so in the next slide, right, I want you to solve this. Okay, I want you to solve this. Okay, so when you solve this, right, I want you to write it in the complex numbers, like the Cartesian form that you see just now. Okay, write this, solve this equation, and then write it in the Cartesian form. Okay, for the complex numbers that you obtain. So I give you a few minutes. Let's do it now. So you have to solve using the quadratic equation. So not sure whether you still can remember the formula. Solve it now. Okay, students, any one of you already get the complex numbers? You can put it in the chat box. You should have a real part and the imaginary part. So you can represent the square root of -1 as a j. Anyone got the answer? You can put it in the chat box. Okay, so from Cheng Hao, negative 3 over 2 plus j square root 31 and negative 3 over 2 minus j square root of 31, then a question mark. So that means he also not so confirmed. Okay, how about others? Do you get the same answer as well? Is it inside the square root is 31? And the real part is negative 3 over 2? Yes, huh? So the real part, is it correct? Negative 3 over 2? Got decimal, okay. Real part is negative 3 over 4, you think. Negative 3 over 4, okay, so have some doubts here. Okay, so that means when we solve this, right, A is 2, B is 3, C is 5. So when we substitute, okay, x equals to negative 3 plus minus b squared. So which is 3 squared minus 4a, which is 2, c is 5. Then divided by 2a, 2 times 2. Okay, so inside the square root, negative 31 over 4. Okay, can you see this one? When the whole thing divided by 4, that means which is negative 3 over 4 plus minus square root of negative 31 over 4. Okay, so now, okay, negative 3 over 4 plus minus, okay, so can you see we have 1 over 4, then inside the square root we have 31 multiplied by negative 1. Okay, so I show you step by step. So I can write it as square root of 31 multiplied with square root of minus 1. So which is negative 3 over 4 plus minus square root of 31 over 4. And then remember the square root of minus 1 we represent as a j. So I write it as a j. Okay, so that means your real part is negative 3 over 4. So your imaginary part is square root of 31 over 4j. Okay. Yeah, so should be negative 3 over 4. Okay. Then the imaginary part is a j square root of 31 over 4. Okay. Is that okay so far? Okay, clear? So that's how we get to the complex numbers. Okay. So as I say, this is a real part and this is a imaginary part. And what we call for this form, we call it as a Cartesian form or rectangular. Okay, this form is Cartesian or rectangular. Okay, so okay, basically we already done the first part. Okay, so just a quick one about the applications of the complex numbers here. Okay, okay, complex numbers are used in the engineering fields, physics, chemistry, biology, electrical engineering, mathematics. So for the application in science and engineering, particularly in electrical alternating current theory and in mechanical vector analysis. So these are the application, okay? And the electrical current equations can be expressed using this is an example. So the electrical current equation can be expressed using complex notation. For example, Z equals to V plus I. Okay, so can you see V is a voltage? The capital I is referring to the current. So the small I is the square root of -1 and the Z is an impedance. So can you see this one is the small I is referring to the square root of -1. Okay, so the capital I is a current. So that's what I mentioned just now. Current we're using capital I. So that's why sometimes instead of using I as a notation for square root of -1, we may using J. Okay, so to avoid the confusion. So this is just one of the examples. Okay, we use the complex numbers to represent the electrical current equation. Okay, so this is some applications of complex numbers to share with you. I believe that complex numbers you will also come in the future when you study for others module, you will always use these complex numbers. Okay, then, okay, I think only left 3 more minutes, so I think I will stop it here. So for the next slide, I will continue tomorrow. So tomorrow, I will still see you at the 3:15 to 5:15. So I will continue for the rest of it. Okay, okay, so we will continue the rest tomorrow. And today we have done the introduction part on the complex numbers. So I hope you understand what is a complex numbers. Okay. Then, yeah, this is the one that you solved just now, right? Okay, can you see this is a 1 if I put it in the fraction? And I may also calculate in the decimal, okay? Okay, then for the previous topics, metrics already done. Okay, then maybe soon I will try to upload some questions for you to practice for the metrics. So I think before come to the okay, we are supposed to have our test 2 during week 9. Okay, since already done metrics, we can have it in the week 9, not a problem. So this week is actually week 7. So week 9 will be on the week of 27. Okay, so I remember last time we have our test on Monday, right? Do you want to still stay with Monday afternoon? So like a 27, then after your class. Okay. If I have your second test on 27, but it's after your class, it's okay. Earlier, you have class, right? If you want earlier, then because I can see most of your classes is on, I can't have it in the morning, because we have students in the different time zone. Definitely, I have to put it in the afternoon. Okay, if I look at your timetable, maybe I should refer to the previous week because this week Thursday you have a holiday. So last time I think I put after your class, which is 4:45 until 6 something, right? Okay, then you can see other day, every day you have class in the afternoon. Okay, so I just try not to put it on Wednesday. If you want also can, but later you have a class 4:15. If everything goes smooth, then it's fine. But if let's say you have problem for the submission, then I'm afraid will affect your next class. So you see all your timetable, afternoon you have a class. Okay, as I say, I can't have it before lunch. I try to have it in the afternoon since some students that have a different time zone can have up to 6 or 4 hours of time difference. Okay, so, okay. So unless you want to have it on the, okay, so Monday after the class, 4:45, since Monday you only have one class, 4:45 until 6:45, okay? So just now I say Monday, which is 27, week 9. So week 7, week 8, week 9. Okay, 27. Just make sure it's not clash with any of your class. Monday, 4:45. Okay, to it's a 1.5 hour. So 4:45 to 6:15 is the answering time. Then again same lah, 6:15 until 6:45 will be the 6:45 will be the submission. Okay, so now can I have, if students agree, can you raise your hand? If you agree with the time, not clashing with anything, okay, raise your hand, please. So for the day, I need everyone to agree with it. Okay, I expecting 14 students raise their hand, or only 13. Who is disagree? Okay. How come we have 13 students? One missing already. One student's missing. Who is missing? Oh, Benny, is it? Oh no, Benny is here. Okay, one student's missing. Okay, doesn't matter. So we will fix it on the 27. So as long as so I block this slot. Okay, in case there's other lecturers say they want to do extra class or anything. So okay, we just block this slot. Okay, for our engineering maths class test. Okay, so anything before I end the class? If nothing, then I will end the class today already. Yes? Any question?
No question. All clear, miss.
Okay, thank you. Okay, so you can put your hands down. Then I will dismiss the class today. Okay, bye, students. See you tomorrow. We'll continue the complex numbers. Okay, bye-bye.
Hi,
Thank you,
miss.
miss. Bye-bye.
Yeah.